So let's move on to the next theorem I want to go over. The next theorem is called the row theorem and mean value theorem. So they are related to each other, okay? So that's why I put them together. So the first part is called the row theorem. So row is a name, okay? So he found this theorem. He says if the function f of x is, first one, continuous, right? And this is a closed interval. And then differentiable on an open interval. Okay, because you cannot take derivative at the endpoints, right? So it has to be open interval, right? Cannot use closed. And number three, if the endpoint has the same value of y, right? Endpoints have the same y value. So same y values. Okay, so first you have to check the three conditions, right? Only if those three conditions are met at the same time, then we are guaranteed to find a number c such that the slope is 0. Okay, so in other words, there is a horizontal line, tangent line at x equal to c, right? When slope equal to 0, that means the tangent line is flat. So here I'll show you with three possibilities, right? It could happen with the pictures, right? So first one, for example, I could have interval A here, interval B here, right? It has to be continuous, right? So no jump, right? No asymptotes. Differentiable means you don't have the cusp, right? Those things. So we'll just make a very simple curve. And number three, the y value has to be the same. So let's say the y value is here. So f of A equals to f of B, and it's at this place. So you have one point here, starts here. You also want to finish at the same y. So one of the possibility is I can connect the line like that, right? So of course, right, this is continuous everywhere, right? And this is a very smooth curve, so it's differentiable everywhere within the interval. So there must be a c so that the slope is flat. So I think I don't need to ask you, right? It has to be here, right? By now you should be able to identify. So this place is the c. Okay, so it shows that the row theorem is true, right? If it's continuous, differentiable, the y are the same, then you get a slope that's flat. The second scenario will be upside down, okay? So for example, one here, they both have the same y, and I make it go down and up, right? So you have c value at here, so flat. Right? And sometimes the third case is, let me draw the A and B. Y value is the same. Sometimes you could have more than one C, more than one places. So how can I make a graph that has that? Let's say we want to have two of them. Does anyone want to draw it? How do you make a graph that has more than one?
Like more than one place where the slope is 0?
That's right. Do you want to try? Oh, there you go. Okay, so we have one place here.
It's kind of ugly, but
okay, that's the word. Another place here, right? So that would be the C. That's another C, and then looks like there's another one there, right? That's a third one. So you can have a lot, right? So as long as it's a nice smooth curve, no broken, right? Then it will work. So let me copy that. Okay, so Jesse, can you help me erase?
yeah.
Thank you. All right, so that will be the three possibility. So the question that you will have will be looking for the C values. So here we have a function, right? This is a rational function. And X is within this domain, right? So this part is called the domain. Find the value C such that, right, in here, right, it has to be in an open interval, such that it satisfies the row theorem. So on the test, when they say row theorem, you have to remember the three conditions, right? You have to make sure you state, just like when you do scree theorem, right? You have to know what scree theorem is about. So row theorem, first condition, what's condition number one, Joan?
Must f of x must be continuous on a closed AB.
Okay, what's the AB here? Yeah, Joan, what's the AB here?
-1 and 4.
Yeah, -1 and 4, right? The interval. So we need to write that out, right? So f of x is continuous on -1 to 4. And then you need to tell me why. Because anyone has a reason? How do you know this graph is continuous on -1 to 4?
Because the asymptote is, the vertical asymptote is at x equals to -5.
Mm-hmm. Yeah, and then what does that mean?
Oh, that means anything on the other side of it is continuous.
Yes, okay, so because it's a rational function, if you remember from previous section, we talked about where the function can be continuous, right? When it's a rational function, it will be continuous on its domain. And domain is when x is not equal to -5. So you can say f of x, because f of x is continuous on x, when, you can say when, continuous when x not equal to -5. So of course, -1 to 4 does not include -5, right? So that's okay, right? So that's why it's continuous on that interval. All right, second thing, what's the second condition? Leon?
Not quite sure.
Well, it's up there in the box. What's condition number 2?
Oh, differential on AB.
Differentiable on where?
-1 and 4.
Yeah, okay. Differentiable. So you need to memorize the three conditions, right? Differentiable on -1 to 4. And what kind of interval, Leon?
What kind of interval?
Yeah, is it closed or open?
Oh, open. Open.
Closed or open?
I said open.
Open, okay. Yeah, so differentiable has to be open. Then how do we know this one is differentiable on there, -1 to 4? What's the reason then? Anybody?
Because it's like, it's continuous.
Yeah,
Yeah.
yeah. Continuous, does continuous guarantee differentiable?
Oh wait, it's the other way around.
Yeah,
My bad.
differentiable then is continuous, right? Continuous could be a cusp, but doesn't guarantee differentiable.
Because left limit equals right limit.
That's for checking that they exist. Okay. So this one actually is using similar reason, okay? You can say because f of x is continuous when x cannot equal to -5, because that's the only place that has a vertical asymptote, right? Not differentiable means it's not differentiable at the 4 places, right? Cusp, jump, endpoint, right? And also vertical tangents, right? So x equal to -5 is the only place that has vertical tangent, right? Because it's asymptote, right? So you get a very steep vertical line, right? A tangent line become very steep. Okay, so it's for the same reason. So when you see the word continuous, differentiable, then you think about not differentiable. Use those to think about why, right? Why is differentiable. Okay, so once we got the first two, right? We still have one more condition. What's number 3, Nicole? What's condition number 3? What does it say?
X is it f of -1 is equal to f of 4?
Okay, so we don't know yet, right? We have to check. So we need to find out f of -1. We also need to check f of 4, see if they equal. Okay, so please plug them in. Okay, sub the value into the function and let me know what you got. Okay, raise your hand if you found the value. I hope they are the same, right? Otherwise, we cannot apply the row theorem. Please raise your hand if you found the y. Oh, the condition says it has to equal, right? Equal each other, yeah. Okay, Carrie, what do you have? F of -1?
0.
Okay, how about f of 4, Joan?
I also got 0.
Yeah, okay, so there we go, right? So it works. So 3 conditions checked. Therefore, we can use the theorem. Okay, so now so the theorem says that if I prime this, I should be able to find a place within -1 to 4 that also equal to 0. Okay, so let's take the derivative. This one needs a quotient rule. Okay. So please finish the quotient rule and simplify it. Once you finish simplifying the quotient rule, please raise your hand. Have you found it, guys? Simplify it. Quotient rule right now should be like a breeze, right? Okay, I'll write down the denominator. Right, denominator should be x plus 5 squared. If you got the numerator, please raise your hand. Jeffy, do you have the numerator? Jeffy, are you there?
Your mic blew up for me. Did you say Jeffy or Jesse?
Jeffy, you.
Oh no, I'm still.
Okay, tell me your answer when you're done. Got it? Not yet?
The numerator, right?
Yep.
2x minus 3 times x plus 5
2x
minus 3.
minus 3.
Oh wait, you mean the factor?
No, simplify the numerator.
Oh, okay, I haven't done that. Yeah.
Okay, Leon, how about yours? What's on top?
I have x squared plus 10x minus 11.
Minus 11. Anyone got the different? Yeah, okay. So that's it, all right? So we got the slope, but then the rho theorem is saying that there should be a slope that will equal to 0, right? Should be a place that has a slope equal to 0. So we take this, right? Because this finds the slope at any place. And I'm interested in the slope when it equals to 0, right? So we want to make the fraction equal to 0, we just focus on the numerator, right? In order
Wait,
for
Jason?
fraction to be
Oh.
0. Yeah,
We can have two answers, right?
that's right. Okay, so
Okay.
if we make it equal to 0, x squared plus 10x minus 11 equal to 0, how do we get the two answers? What are the two factors?
X plus 11,
Yeah,
x minus 1.
minus 1. So we get x equal to 1 or negative 11, right? Those are the places that has a slope equal to 0. But do we keep both answers?
No, because negative 11. Oh, wait, never mind.
Is there a reason that we should reject any answer here?
Wait, are we looking only for in between negative 1 and 4, though? Because that's the domain.
So take a look. Does the question tell you to look inside there?
Yeah.
Yes, okay. Find the value c, right? Even though it says c, right? C is like x, right? C is some number. inside -1 to 4, so that is satisfied. Satisfied means it meets the requirement and also slope equal to 0. So the only place that sits in between is what? Which one? Yeah, which one is in between -1 to 4?
1.
1, right? So we only keep this one. This one you will reject. Okay, so you did all that work, but at the end you forgot to reject, right? So that will be a very pity, right? So this one will be the answer, okay? In domain. Okay, so make sure you double check the domain, okay, when you finish. So the thing I noticed right now, right, a lot of you are still not fast enough in doing derivative, right? Finding derivative, chain rule, quotient rule, product rule, those are only your tool now, because now we are at the stage of applying it. So you got to do this very quickly, okay? So if you are still not doing fast enough, that means your algebra, you need to practice more, like expanding, right? Combining like terms, those things, okay? And factoring. All right, so the next part, mean value theorem. Mean value theorem is like an extension of row theorem, because row theorem is only limited to the y values are the same, right? Up there, it's required the y value to be the same. So the slope is equal to 0. Now, what if the endpoints are not the same, right? One higher, one lower. So that's what mean value theorem is talking about. So here we take away the last condition, right? We only have 2. Continuous, same thing, right? Closed interval. Differentiable, right? Unopened interval. But it doesn't require f of a to be the same of f of b. It could be the same, right? But doesn't have to be. So that means row theorem is included inside mean value theorem. Okay, so let's go back. So row theorem will be like a special case of mean value theorem. So on the previous page, you can write it down. Wrong place. Down here. Okay, row theorem is a special case of MVT. Okay, mean value theorem. So let's look at the theorem now. If A and B, right, 2 numbers, then there has to be a number C inside A to B, same as before, right? But this time, instead of f prime of C equal to 0, we have f prime of C equal to this one. Can anybody recognize?
Isn't that the same slope thing though?
What do you mean same slope?
Like y2 minus y1 equals x2 minus x1.
That's right. Okay, so this, the right hand side is just represent the slope between 2 points, right? The 2 endpoints, right? A and B, they are the endpoints. So slope between 2 points. So delta y over delta x, right? And then the left side is the slope of tangent. So it's just saying that there will be a slope of tangent somewhere in between the interval such that it equals to the slope of the endpoints. So let's think about what we had before, okay? We'll look at 2 pages at the same time. For the previous one, right? F of A has to equal to F of B. So if that happens, what's F of B minus F of A?
0?
Yeah, so that's why F prime of C will equal to 0. So the row theorem is included inside the mean value theorem, right? When we make f of b minus equal to f of a, then it becomes Rolle's theorem. Do you get this part, this logic, right? When f of a equal to f of b, then mean value theorem becomes rho theorem. Any question here? Can you raise your hand if you get what I mean? Nicole, any questions? Yeah, okay. When f of a equal to f of b, then they subtract or equal to 0. So that's why in the previous one, we got f prime equal to 0. So let's show a picture as well, right? So this time we have a and b, they are the different height. So let's say I have a down here then, okay, lower. So this is f of a. And b, let's make it higher. And then let's just make a simple curve. Right? So the mean value theorems, if it needs to work, it has to be continuous. So we check, right? This is continuous, differentiable, right? Now there has to be a number c such that the slope of tangent is the same as the slope between the two endpoints. Okay, slope between two endpoints, I'm gonna draw it with the green line. So this is delta y over delta x, right? Slope between two endpoints. So where can I put the tangent line so it has the same slope? Can someone draw it out? Where will be the tangent line so it has the same slope? Anyone?
That was supposed to touch. Let me redo it.
Almost. Pretty parallel. Very good though. Yeah, where? One more time. Yeah, okay.
Yeah, I'm kind of close. You know what I mean?
Yeah. Okay, so let me copy your point in your line. Okay, you can clear that now. Thank you. So that's where it touches, right? So we trace down, then that will be the C that we're looking for. Okay, so this is the question mark. Okay, so mean value theorem is looking for the place, right? The location such that the tangent line has the same slope as the slope between the 2 points. So why is this called mean value theorem? What does mean means?
Like average.
Average, yeah. Average. So average is like, so the average value, okay, is over here, this part, the slope, the location of the C, this place is where the, when you find the slope, it's like finding the average, right? So this location is like the average slope of all the slope that you have in between. So for example, you could have something that's steep, right? And getting less, right? And then you have something that's flat, right? Something that's negative. And then average value, right? Mean value theorem is we take all the slope and finding somewhere in the middle. So that's why they choose the endpoints, right? When you find, it's kind of like finding average velocity, right? You don't care about what's happening in the middle. You just look at the two endpoints and get the slope. Then that's the average velocity. So average velocity is like the average slope, right? So the slope that you get using the endpoint, we call that the average slope, which is also called a mean value. All right, so they just give you a different name, okay? But if you understand it from average velocity, it's the same meaning. Now the second picture is just trying to make an example saying that there could be more than one, right? So I could reverse it. I could have A higher, B lower, and I want to make it more than one. So I make it more curvy, right? For example, like that. Then the average slope, right, or mean value. slope will be this one. So where could be the tangent line that could have the same slope? Can I have someone else to draw it out? Any other volunteers? Where
think
will be the tangent line? Yeah, Jeffy? You want to try?
Yep.
Okay. Pretty hard to draw, huh?
Yeah. Let me.
Takes skills. Yeah, you got it.
Have another
Is there
one.
another place? Yeah, very good. Okay.
But it
So
gets
parallel. So it'll be touching like somewhere here. Okay, can you help me erase the lines? All right, so those are the two places, right? So it's showing that there could be more than one answers in your C, right? So just like in the last questions, we also found two answers, right? 1 and -11. But then make sure you only keep the one inside the domain of interest. Okay, so I'd like you to try question 14 now. So same process, all right? So try to explain why it's continuous, why it's differentiable, right? And then apply the mean value theorem to find C. Okay, so if you find the value C, please raise your hand. And also make a picture, right? To show that it's where it is, right? Just from -2 to 2. We only have two conditions to check. So first one, you can write F is continuous on closed interval because, okay, I'll wait for you guys to finish. F is differentiable on open interval because and then after that you need to calculate.
Wait, for C, do I just pick any random number or?
No, you have to find C, not picking. You don't pick number. You are finding C, right? You are finding X, just like the X that you found before is the C values.
Oh. Oh, okay. And then it's equal to 0?
No, not equal to 0. Equals to the slope of the endpoints.
Oh, okay.
Yeah. So left side, you need to do prime. Right side, you need to do the slope of endpoints, and then you make them equal. All right, let's check the reason, okay? What's the reason that it's continuous? Joan, what do you think? Why do you think it's continuous on -2 to 2?
I don't really know what to write out, but I mean it just says that the function exists on close bracket -2, 2. So
Okay, we need a more concrete reason. Anyone knows what will be a proper reason to say?
I said because the domain of x cubed is all real numbers.
Mm-hmm. Yeah, okay. And now, okay, I'll refer to you exactly where you need to look at, okay? So let's pull back to continuous, right? Continuous at the point. So that's quite far back. Let's see which page that is. Limit low, not limit low. Continuous point.
Wait,
Yeah.
is it because left limit equals right limit?
No limits. Okay, over here. This one, you guys can also flip back, okay? It's a good chance to review, right? Things that's going back. Okay, this one, page what? Page 24. Properties of continuous function. Right, so for example, first one, because it's a polynomial, so it's continuous on real number. It's a rule, okay? So if it's absolute value, then it's continuous everywhere, right? If it's rational or radical, then it's continuous on the domain, right? And if it's a continuous function, they do operations, then the resulting function is also continuous, right? And if it's continuous function and then you put composite, then the resulting function is also continuous. Okay, so this page, right, you can make a note, right? Look at page 24. So for checking continuous, how to write out the reasons. Okay, so let's go back to there. Right, so the reason that we should be using is just saying f of x is continuous on there because it's a polynomial. That's all you need to say, right? You need to recognize it's a polynomial because it's a rule that for polynomial continuous everywhere, okay? And then differentiable for the same reason, okay? Polynomial is differentiable everywhere. Okay, now next part. Now we need to find the value c, right? Such that the slope at that place has to be the same as the slope of the endpoints. Let's get the slope of the endpoints.
Hey, Jason,
Yeah, Jesse.
is it possible like we have a plus minus?
It could be, right? You could have more than one, right?
Wait, but how does that work then? Because then the slope might not be the same.
Slope has to be the same.
Oh wait, I meant like it's not parallel.
At different place, right? Slope
Oh,
is
okay.
the same, but then the x value is at different place.
Oh, okay. I see. Oh, okay, yeah. Never mind. Sorry,
Okay, you
thank
can
you.
also draw the picture out, right, to
Yeah.
double check if it makes sense.
Okay.
Okay, let's check the slope between two endpoints. So f of 2, right, minus f of -2. So the y value change, y2 minus y1 over 2 minus -2. I'm doing the right side now, okay? Just the right side, slope between 2 points. The denominator is 4, okay? Numerator, f of 2 is 8. F of -2 is -8. So that's what, 16 over 4, so 4, right? Now the left side is the slope of tangent, right? Take a look at the formula. Right side is rise over run. Left side is the prime, right? So I need to prime the function. Okay, so prime of that is pretty easy. This is 3x squared, right? 3x squared, 3x squared. And then we try to find out where they equal each other, right? Slope of tangent has to equal to slope between 2 points. So we solve for x. When you found the x, can you raise your hand? Jesse, have you found it? Yeah?
Oh yeah. So I kept raising my hand because my thing, like my screen glitched for a second, so I like pressed it multiple times. I didn't know if it was up or down.
Yeah, sometimes it froze. Okay, Leon,
Okay, it was up. Sorry, my bad.
Leon, what's your answer?
I got 2 over root 3 and -2 over root 3.
Yeah, so plus minus, right? So the x, even though we write x, right, but in fact it means c, right? Because these are the places that makes the slope equal to 4, right? 4 is the slope between two endpoints. Let's try to look at the same this question again, but with the picture, right? The function is x cubed, right? So let's graph it out. At 2, it will be 8. So the point is here, right? Different scale. And then, so that will be 4. So 1 will be here. So 1 will be 1, right? And then 0, -1. Let's say here's -8. So if we draw the curve, go something like that. Right? So we are looking for the slope such that it equals to the slope between two endpoints. So I'm going to draw the green line. Green line is the slope of 4, right? This line has delta y over delta x equal to 4. And then we found two answers, right? We found one is positive, one is negative. How big is 2 over root 3? What's that in decimal? Can you help me? What's 2 divided by root 3?
It's 1.1547. So like 1.155 or 1.15.
A little bit more than 1, okay? So here's 1, a little bit more than 1 will be there. So that will be here. That looks about right, right? If we draw a tangent line, it'll be the same, right? So that place, that's one of the C, right? Another C will be -1 point something, right? So go down. And then we make the tangent line. And that will be parallel, right? Also has a slope of 4. So that would be the C. So that's what it means. All right, so this is the very basic part to find, just to find the value of C. Of course, it has different way to ask you to apply this. We are not going to do question 15, it's the same thing, okay? Just a different polynomial. and 16 is same thing. So let's look at question 17, okay? Another way, instead of asking you to find C, somehow it has to do with average mean value theorem, okay? So I would like you to think about this. Let you try this first by yourself. So it tells you a point, right? F of 2 equals to 8. And then it tells you that the slope of tangent, right? Try to translate, right? Translate into plain words. Slope of tangent is lower than 4, right? Lower or equal to 4 on this interval, right? On this interval. Now it's asking how large means how high, right? What's the y values, right? Can this f of phi equal, right? What will be the largest? Right? How large means looking for the maximum. What's the biggest value for f of phi? Okay, so I'll let you think about this first. You can try to draw pictures or something, do calculations. So of course it has to do with MVT. Jesse, you found it? Finished?
I think so.
Okay, so what's your largest value for f of 5?
I got 20,
20. Okay.
except I'm like 99% sure it's wrong.
Okay, you are so sure. Okay. Anyone else? Or how about like by now, right? After thinking for a while, can you show hands if you have no idea what he's talking about? Okay. Well, almost everyone. So some of you are still trying. Okay, maybe I'll give you a little hint, right? So let's draw it out, right? F of 2 equal to 8. So let's say here's 2. Here's 8. Okay, so I have a point. Right? F of 2 equal to 8. And it says between 2 to 5, right? So 5, let's say, is here. How large can this be, right? So it says the slope has to keep it under 4. So let's say if I have a point, let's say here, right? I just make a random dot. Now the curve can go any way they want, right? It could go like that, it could go like that, right? But because of mean value theorem, I can find the slope between 2 and 5. Then I know for sure somewhere in the middle, right, you could have slope that is the same as the green one. Okay? So if I raise it higher, right? Right now the green line doesn't look like it's 4, right? I could make it higher. So let's say if I change the point at 5 a bit higher, let's say higher, let's say here. And then the graph can go something like that, right? Then I want to make sure the slope of tangent line anywhere here is always less than or equal to 4. But how can I guarantee that? So I just check the endpoints, right? Mean value theorem says that if I can check this point, slope between 2 points, and check that slope. So let's say if I find this slope is 7, then I know somewhere in the middle could also have 7. Then that fails the condition, right? Because the condition says it must maintain lower than 4. Okay, so that will be the hint I gave you, how it connects with the mean value theorem. Okay, think about it. How can we use it to find the highest place?
I have the same answer as Jesse then.
Yeah, okay. So if you have an answer, please raise your hand. Joan, what do you have?
I also got 20.
20. Okay, Dion.
Same.
Okay, very good. Okay, let's go over it. Okay, so based on what I was saying, right? You want to make sure the slope of tangent everywhere, right? Everywhere to be lower than 4, right? So that means you must keep the green line lower than 4, right? Because green line is kind of like the guaranteed slope to appear, right? So we just take the slope. We want to make sure the slope between 2 points to be less than or equal to 4, right? Because that will guarantee the slope in between is less than or equal to 4. So that's the idea, right? So we just sub it in, right? F of B is 5. F of 5 minus F of 2 over 5 minus 2 less than or equal to 4. And F of 2 is given, right? Minus 8 over 3 less than or equal to 4. And then from there, you isolate the F of 5. So cross multiply, so that will be 12 plus 8. So F of 5 has to be smaller than or equal to 20, right? If it gets higher than 20, right? So this is 20. 20 will be the maximum it can rise up to. If it goes up to higher than 20, then your slope could be higher than 4. Okay, so that's the idea. So maximum value is at 20. All right, any questions? Last thing I want to talk about, right? Not too much calculating, more of a concept, all right? So that can help us get prepared for next week's. So it's next page. It's talking about max and min. Sorry, not max and min, monotonic, okay? So I want you to circle this word, monotonic. Mono means what?
1.
1, okay? 1, single, right? 1. How about tonic?
Tonic water tastes kind of nasty. Like it's like kind of bitter, but also has a bunch of sugar. It's like really disgusting.
Okay, so it's a 1 single bitter candy. Right.
Wait, are we not talking about the same thing?
No, not talking about the same
Okay,
thing.
never mind.
Okay, monotonic is going in one direction. Okay, so this is like direction, not a bend. Okay, so monotonic. So it's a function that goes in one direction, right? So if it's only increasing within that interval, then we'll say it's monotonic on that interval, right? And then, or just decreasing. So over here, right, you have a, just deal with simple function, continuous, right? Just like before, differentiable on open interval. if the slope is greater than 0. Okay, circle that, positive, right? Then it means it's increasing. I think it's very common sense now, right? If the slope positive, that means going this way, right? All these slope are positive, right? Just steeper. So all of these, if their tangent line are positive slope, then you know the function is going higher and higher. Increasing is talking about from left to right. Okay, always from left to right. And then if it goes higher, we call that increasing. And then opposite is negative slope, then it's decreasing. Okay, then we just say it's monotonic on that interval. Okay, and make sure pay attention here, we are using closed interval to describe the increasing, decreasing. Okay, so over here, we are just practicing writing out the interval. And then we'll write out from left to right, okay? So that I'll go over the increasing one together. Okay, so positive slope means increasing, right? Function is increasing on, so let's take a look, right? Between positive and negative, it has to be 0, right? So 0, let's find all the 0 slope place. So that one will be here, right? Another one will be here. Another one will be here, that's flat, right? And then no other place. So the places that has increasing will be like this one, right? All these are positive slope. So the first interval we can write is from, let's count, okay? That will be 1, 2, 3, 4, 5. -5 to -2. Right? That's the first interval. The next interval is going to be increasing, will be the one here, right? Positive slope, right? And looks like we are having, we have a vertical asymptote, right? So we'll start from where? What's the starting point then? Joan?
0.
Yeah, and what's the ending place?
2, but it wouldn't be closed.
It will be open, actually, yes. Okay, because it cannot touch 2, right? So function will be increasing on those 2 intervals. And then,
Jason,
yeah, question?
are we allowed to have the open bracket though? Because doesn't the thing say it's increasing on closed interval?
Yeah, so because the interval does not close, right? So it will be continue increasing before the close interval.
Oh, so we're just using that just to say it's like right before 2.
Yeah, yeah.
Oh, okay.
What that means is, yeah, it doesn't increase at the point till that it's not increasing until that point is right before the point. Okay, so can you guys write out the decreasing one then? Okay, when you finish writing, raise your hand. And please write it from left to right. So the first part will be there, right? Those are decreasing, right? These are all decreasing. All are negative slope.
Wait, Jason.
Yep.
For the negative part, like if even if the slope gets less negative, it's still negative, right? So we can still count that as part of the interval.
Still is decreasing.
Okay.
Yeah. If the tangent line is negative, then it is decreasing at that place.
Okay.
So Lex, can you give me the first interval on the left side? Huh?
Open bracket.
Open bracket, yes. And then?
Negative infinity.
Yeah.
And then negative 5
Yeah.
and square bracket.
Okay, thank you. Okay, if you finish, please raise your hand. 2 more intervals. Okay, Nicole, what's the second interval from?
I got bracket -2 and 0 bracket.
Okay, very good. Yeah, and Leon, last one.
2 and infinite open bracket for both.
Yep. Okay, that's all right. So next we will talk more about increasing, decreasing. Okay, I'll see you next class. Bye-bye.
Bye.
Bye.
See you, Jason.
Bye.
Bye-bye. Good night.